In this quick screen cam we're going to have a look at a DHCP capture inside Wireshark. Okay, so let's open my DHCP example file. This was captured on a wireless network. I'm going to ignore some of the wireless complexities for the moment and just focus on DHCP. I'm going to put a display filter in to actually analyze only DHCP traffic. To do that, I type bootp. That's called the Bootstrap Protocol, on which DHCP is based. Right, the first frame that we can see here, frame 7, is a Bootstrap Protocol. Let's have a look in detail. Ethernet 2. We have a destination MAC address of a 3COM device, and we have a source network address of an Intel device. It's useful to know a little bit about the computer network. The 3COM network address here, this MAC address, is actually a multi-layer switch. Let's have a look at the IP addresses assigned to this particular bootp request. Here we have the source address 172.30.253.1 talking to 172.30.250.1, so it's crossing subnets. These are /24 subnets. We see the time to live field is set to 128, standard default value. Let's have a look at the UDP. We've now moved up to the transport layer. We can see that the source port is bootpc, Bootstrap Protocol Client. That's UDP port 68. We're talking to the Bootstrap Protocol server, bootps, on port 67. These are standard numbers. We have a checksum here in this layer. Remember, we always had a checksum down here in this layer as well. So we've got lots of validation to prove that the network is actually working okay. Let's go into the Bootstrap Protocol. Okay, we have a huge amount of information inside here. Let's go through it. We are on Ethernet. The client IP address is a device asking for an IP address. It says its address is 172.30.253.1, and we already know that because that's the address it's talking on. Your client, next relay, relay agent, those are advanced functions. Client MAC address, this is my network card address. So it may be in the physical layer, but it's also embedded inside the application. We do that so that we can actually allocate, based upon the network card, specific addresses. Server host names not given. We look at the option 53. We see it's a DHCP type message. So bootpc, boot protocol or Bootstrap Protocol Client 53 option is DHCP. We now go into the client options. We can see the MAC address, we can see Ethernet, and we can see some details here again. If we go into the option, a further option, we see the host name of this laptop or this system, CNT-lap1. There are some other options, some other numbers inside here as well. We have a class identifier, MSFT 5.0, Microsoft, version 5.0. Okay, and that's obviously part of their networking stack. Options again, parameter list. We're asking for specific information inside this. We're asking for the router name, the subnet mask, the domain name server, net BIOS over TCP/IP, and so forth. So we're asking for quite a bit of information in our DHCP request. For reference, chaps, this down the bottom here is the binary data that was captured on the wire in hexadecimal format. You can often read fragments of it if you know what to look for. That was the client, that was the request for an IP address. Let's look at the response that comes back. All the top headers are almost exactly the same, apart from this time the source and the destination are swapped and the source and the destination IPs are swapped. Let's go into the details. Client IP address 172.30.253.1. That's who we were. It's now been filled in from the server, so the server has given us the same address back. It's told us that the relay for that network was at 250.1. so we can see that the server's inside the 250 network. There is no cascaded relay. We move down to some of these options. Server identifier. We now know that the DHCP server was actually at 250.1. We can see a lease time. The lease time is 10 minutes. We can see the subnet mask, /24-bit. Okay, 255.255.255.0. We can also see here a domain name. The network that we have been given, 172.32.50, is domain name registered to housewireless.ric. There's some more binary string values there as well. How do we get out of our network? How do we get out of that subnet? We talk to 172.30.253.254. That's the highest address in /24. That's the address of the router. We then look at domain names and domain name servers, and we're given two addresses, 172.30.251 and 192.168.251. These are two addresses of two different DNS servers. They're on different networks. So, we have analysed quite a bit of information here in DHCP. There's a DHCP request and an acknowledgement. If we remove down a little bit further, there are other message types as well. In this case, there's a release, as we see in this flag. A release, a discover, an offer, a request, an acknowledgement, and an inform. I'll leave it to you now to go through some of those. That's the end of this screen cam.